So notes 23.999. Not quite notes 24. We'll still need to talk about mean value theorem. We're just going to wait for MVT until we come back from the break. All right. If a function, so we're talking about a function. So when I say function, we're literally talking about f of x. So when it says first derivative, they're talking about f prime. When they say second derivative, they're talking about f prime prime. Cool? If a function is increasing, the first derivative is positive. Look at you guys. All right. Ready for the next one? If the first derivative is negative, so if the first derivative is negative, the function is decreasing. If a function is concave up, now don't answer real quick. Think about it before you answer the answer. If a function is concave up, the second derivative is positive. If a function is concave down, the second derivative is negative. How do we know that? Okay, because if a function is concave up, notice what happens. Let's call this f. Notice what happens to the f primes. F prime right there is like negative 10. F prime right here is like negative 8 or negative 5, then 0, then 2, then 5, then 10. So notice that f prime is increasing. If f prime is increasing, that means f prime prime is positive. So when the second derivative is positive, because f prime is increasing or my slopes are increasing, that's what creates a concave up graph on f. Make sense? Okay. Here we go, guys. If the second derivative is negative, the function is concave down. Does that make sense to you guys? Okay, now we're going to be talking about different stuff here. If the first derivative changes signs from positive to negative, our function has a maximum. If the first derivative changes signs from negative to positive, our function has a minimum. I should have written more. There's only 9. Darn it. If the first derivative is increasing, the function is concave up. First derivative increasing means f prime prime is positive. So maybe you might want to circle that and put f prime prime is positive. Yeah, I should have made a 10 and 11. Sorry, guys. If the first derivative is decreasing, the function is concave down because the first derivative decreasing means f prime prime is negative. Does that make sense? Okay. Turn the page. I don't remember where I got this graph from. I don't remember if it was a released AP exam or... You okay?
Oh.
Sounded like a ship.
No, that's how I yawn.
Okay. You know, like when they're going into Harvard, like, ooh, okay, I'll stop. I was looking for a ship immediately.
I know what you mean.
Yeah, like, where's the boat? Like, okay, sorry, guys. Did it not sound like that? It did sound like that, right? Okay, I'll stop, guys. Sorry, miss. We're all good. All right. No, she doesn't feel bullied. We're good. All right, here we go, guys. Here we go. So the graph that we're looking at is f prime. Cool? All right, so here we go. It says, the figure shows the graph of f prime, the derivative of function f. The domain of f is a set of all real numbers such that x is between -3 and 5. Okay, I can see that. For what values of x does f have a relative max? Y. So we're not including the endpoints. That's fine. Where do I have a max? On f. Yes, y.
Because learn from positive.
Perfect. So that's what you're going to write. You're going to say f has a max at x equals negative 2 since f prime changes from positive to negative at x equals negative 2. I don't know, it sounds redundant to say it again, but say it again. Letter B. For what values of x does f have a relative minimum?
4.
Why?
Because it goes from negative to positive.
Okay, don't say the word it.
F prime values go from negative to
You can just say f prime. F prime goes from, yeah, avoid the word it. Do not say, as a matter of fact, do not say the word it, because if you say the word it's going to be wrong. You're not being specific. What is changing from negative to positive? So say f has a min at x equals 4 since f prime changes from negative to positive at x equals 4. Are we okay so far? Yeah. Okay. Letter C. What intervals is the graph of f concave up? From negative 1 to 1, and there's another one.
And then from 3 to 5.
Why? Because f prime is increasing. That's what you're going to say. So you're going to write f is concave up on the intervals negative 1 to 1. So you can put parentheses negative 1 to 1. As long as you say the word interval, we understand that means an interval, guys. And don't put brackets on this. Always put parentheses for concavity. And from 3, I don't like the union on this one. I think this one is better to use the word and. It's the same. You'll be fine. But I think just spelling out the word and is better. Okay. And 3 to 5. Since f prime is increasing on these specific intervals. Full credit. Let me read it again just in case. F is concave up on the intervals negative 1 to 1 and 3 to 5 since f prime is increasing on these specific intervals. Perfect. Full credit. Remember what this means, guys. If f prime is increasing, that means f prime prime is positive. Cool? Now, on any exam, you can probably get away by saying f prime prime is positive, and they would probably mark it correct. But you always want to reference the graph they give you. Does that make sense? Because remember, just like I told you guys last time, when you guys become medical doctors, not everyone you speak to will know what you know. Does that make sense to you guys? So your population is not always going to be a math-oriented population. So that's why you always want to reference whatever. Obviously, you still got to know that f prime is, the derivative of f prime is f prime prime. But you guys know what I mean. Always reference your material that you're using. All right. Letter D. Suppose that f of 1 equals 0. Draw a sketch that shows the general shape of the graph of the function f on the open interval 0 to 2. Now, okay, I'm going to slow down. When you were taking delta, this is why I'm not in love with delta on all the subtopics. When they give you an f derivative, they told you that it was impossible to know whether f of whatever value was positive or negative. That means because f could be drawn like way above the x-axis or way below the x-axis. Does that make sense? But it's not impossible to know. It's not impossible to know. They just have to give you a point. And then once they give you a point, then you can figure out whether it's positive or negative. So I don't like that ambiguity that they just say it's impossible to know. All right, so they're telling us we're only going to graph from 0 to 2. So the first thing you're going to do, let's go ahead and create a grid. There's my grid. When x equals 1, what is my y value? 0. 1 comma 0. This is f. So go to 1, and I'm going to say 1's right here. I'm going to put a point at 1, 0. Yay or nay? Okay. Now, let's look at our derivative. Between 0 and 1, I'm looking at this part right here. F prime is increasing, so that means F is concave up, but F prime is negative because I'm below the x-axis. So that means that F is decreasing concave up. Does that make sense to everyone? Right at 1, I better have a horizontal tangent. So here's what you're going to do. So right at 1, I better have a horizontal tangent. So I probably look something like decreasing concave up. I look something like this. Like a parabola. Let me draw it better. How do we know it's concave up? Because F prime is increasing. Yeah, we know it's positive because at 1 it should be at 0. All right. Are we still okay, guys? Between 1 and 2, is that all they wanted? Wow, that was all they wanted. Between 1 and 2, F prime is decreasing and F prime is negative. Does that make sense to you? So that means that F is decreasing but concave down. So decreasing, concave down.
I have a question.
Yes.
You said which is it F? F is concave down on the top. How do we?
Yeah, F is concave down because
Prime
F prime is decreasing. F prime is decreasing means F prime prime is negative. If F prime prime is negative, F is concave down. You know what I mean? Or no? No, tell me. You okay, Gonzalo? Oh, okay. Yeah, you're trying to put too many things at one time. So just go slow. Is F prime below the x-axis? So if F prime is below the x-axis, that means my slopes on F are negative. So I better be decreasing. Does that make sense? Okay, next. Is F prime, I'm looking at the graph F prime, this part in green, is F prime decreasing? Yes, so that means F prime prime is negative. If F prime prime is negative, what do we say over here? If F prime prime is negative, where are you? Second derivative. If the second derivative is negative, concave down. So do you see what we're doing? So decreasing, concave down. So there it is. This is how the graph of F looks like. Only between 0 and 2.
Well, no, I'm just saying because I did it on my own and I thought it was wrong. But
No,
it's right.
you did it right. All right, guys. So here's what we're going to do.